Hi, my name is Alfredo Deza. I'm a former Olympic athlete and have extensive experience as a software engineer, primarily working in Python, with a solid background in automation and systems engineering. I've worked extensively in many different companies, deploying production grade code and services, automating, creating CI/CD environments. And today, I specifically want to talk to you about how to put together a highly robust process to deploy a web application through containerization of this web application all the way to Azure. So from some local code that you will in turn use to perhaps make it your own and make some changes along the way, through GitHub Actions, push it to a repository, and then automate it and make a push button deployment so that at the end of the day, this gets deployed with minor changes all the way to Azure. And then it can be served throughout the entire world and take advantage of all the goodies that Azure provides to make it a highly robust, scalable web application through containerization. There are many options, there are many steps involved, so let's take a look at how we can build those today. Okay, so here we have an architectural diagram of what we're going to build in this course. We're going to start here in our workstation. I'm going to say this is number one here at the very bottom. So our workstation, we're going to do some stuff locally. We're going to try our Flask application. We're going to run that locally. We're going to set some ports, ensure that our Python application is running correctly. And then we're going to set some automation over here. So that's step number 2. So we're going to go from step number 1 all the way to number 2. We're going to set some automation via GitHub Actions. I'm going to set some YAML files and some instructions on how exactly that's going to happen. And when we arrive all the way to GitHub Actions all the way here, what's going to happen over there is that we're going to build a container. And one thing that I'm not showing here is that this container is going to get pushed to, in GitHub it's called GHCR, which is a GitHub container registry, and I believe that's ghcr.io. So that's the domain. And this is going to be a registry. That's where we're going to have our container getting pushed. Now, once that happens through an API and through the GitHub Actions, so this is going to be step number 4, then we're going to deploy to Azure. But instead of following what you see here, what's going to happen is that Azure is going to get the instruction. That's all right, like happening through the API over here. However, when Azure gets the instruction to start deploying, what's going to happen here is that Azure is going to actually talk to the GitHub container registry and pull that container that we built and pull it down. Now, you may be wondering, like, wow, like this looks rather complex. Now, it's not that complex. I mean, there's a few steps happening, but this makes it much easier. So for example, if we look at the very bottom on step number 1, if things are not working there, well, you're not going to progress to step number 2 or 3. Actually, the automation is going to be set up for you, but the container is probably not going to build. If the container builds here on step number 3, then that's fine. It will get built to the GitHub container registry. Now, what gives you a solid, robust process deployment here is that you're going to have everything versioned. So the automation in GitHub Actions is going to allow you to have things in version control, so you can check, make changes, and automatically deploy. So that's it. That's how we're going to build this whole application that at first sight it kind of looks rather complex, but not quite. And we'll take it slowly, step by step, and we'll get to a very robust push button deployment of a container service using Flask. Let's take a look at the files that we're going to be working with. In this case, This is a GitHub repository with all of the files that we're going to be using, and it's a containerized web application that is going to be using the Flask web framework. The Flask web framework is pretty straightforward, but we'll see with each file what are we going to be doing and how that's going to play into this little application. So let's start at the very top with this web application, or web app directory rather, and it's going to have like a single file. That's it, and it's going to be just a few lines long, and it's going to import Flask. It's going to set some variables there, and the application is going to do some routing, and it's going to map those routes to different functions. Now, I'm not going to go into the details right now because we're just looking at the files and what each file is going to be doing. So we'll leave the details of this file for later. Now, let's go all the way back, and in our container, in our GitHub repository containerized app, we're also going to have a Docker file. Let's take a look at the Docker file and go top to bottom at the things that we're going to be doing here. First, we're going to declare that we're going to use Python 3.8 as the base image, and then we're going to copy the requirements, that text file that exists in our directory, over to the container. We'll see what the contents of these requirements, that text, is next. Then we're going to set the working directory to web app within the container, and then we're going to install the requirements inside the container. Again, we're going to see the contents of this file in a second. Finally, we're going to copy the contents of the web app directory from our repository into the container, which means this one single file that we just saw that imports the Flask application. Finally, on line 11 and line 13, we're going to say we're going to run these with Python and then app.py, and that's how our application is going to be running. So let's go back up to the top of our repository here, and finally let's take a look at the requirements.txt file. So this file will declare a single dependency. Flask is an external dependency. We need to tell the container, hey, this requires a web framework, and in the library, the application is called Flask, and we want that to be at version 2.0.0. So that's it. Those are all the files that we need. I'm not covering the git ignore, which has files that we don't want to add into this repository, the README, which has some text explaining what this project is about, and then the license, which do not have anything to do with the web application itself. That's it. That's the project structure, and we will see what we're going to do next with this. Now that we know the files that we're going to be working with and kind of like the structure and what is it that we need to create a virtual environment. That's the basis of any Python application. So let's go ahead and do that. The way we're going to do this with a terminal, I'm using Visual Studio Code here and running a terminal in it. I'm going to say Python 3-m VM. And then that basically says, hey, I'm going to use the VM module, and then I'm passing the path that I want to use to create this virtual environment. So that's it. I've created this .vm file over here. I'm going to activate it next. So I'm going to do source.vm being activate. And I type over there, and the terminal is telling me. So now you can see that I have a .vm in my prompt. That's fine. And next, we're going to say I'm going to install my dependencies declared in the requirements.txt file. If you remember, that's over here, and it says Flask at the version of 2.0.0. So I'm going to be using pip install -r requirements.txt. I'm going to be doing that, and it's going to collect everything that it needs for my application to run. Now, I'm going to try to run this locally because that will allow me to ensure that whatever I'm doing here will be working fine. Next, we need to go into web app and app.py. And here at the very bottom, the one thing that we want to make sure is that this will run on any host. Or any IP. That's why we're specifying a host of 0.0.0.0 that tells Flask, hey, just run and bind to any address, associated with this machine. So that's great, but this port 80 will not work in my machine because it will require me super user permissions. Now that's a thing that you will need when running on the Azure side of things, but we will not go into the details of that right now. Let's go and change this to port 8000. So I'm going to save that. And then what I'm going to be doing is, I know that I have Python here at the bottom. I have the terminal at the bottom. What I want to do is run the exact same commands that I would have here with the Docker file. So we've installed the requirements, we've created this virtual environment, and now I'm going to run python app.py. Now, in order to run python app.py, I need to be within this web app directory. So let's change directories into web app. I'm going to clear this so it's a little bit cleaner. And you can see there's app.py. So now I'm going to run python app.py, and let's see what happens. So that's running, and it says it's running on all of these IPs. You can see it's running on both, and localhost and port 8000. So if I go to my web browser, and I click this, it will say that there's a 200. So you can see that right there. And if I do /error, you can see that there's an internal server error. So again, if I go back here to Visual Studio Code, you can see that it sees that there are some requests coming, and the browser wants to get a favicon.ico, or this file that doesn't find because I don't have that. It's a 404, but then it goes to error. So now that it's running locally, we can say, well, we have high confidence that we can now convert this into a containerized application. But this is the first step, because it allows you to have confidence in that what you're running locally will be able to run as well in a container. Let's take a look at app.py here and go through some of the things that we've done, because we haven't covered the details of what we're doing right here. So line number 1, we're importing Flask, and we're importing abort, which is a function that will help us error out when something is not quite right. Then on line 3, we're declaring this application. We're initializing this application from Flask. We're using _name_, meaning, hey, the name of the file will be used, or the module will be used as a Flask, as part of the Flask application. And we are routing, like so, / is going to be mapped to this function. Is saying, hey, there's a 200, no problem there. Line number 9 is going to say anything that goes to /error is going to be using this function over here. The function can be named anything. In this case, I've named it also error. And I'm calling abort, which requires the HTTP error that we're going to pass, and then the text I'm going to be returning. Finally, on line 14, I'm saying, if this gets executed, that's what this line 14 does. If this application, this file gets executed on the terminal, this line 15 will run, which calls app, the thing that we initiated here on line 3, and it's going to run with these options. You can see debug equals true. That's usually useful, not recommended for production environments. And it will bind to every single IP, and it will use the port of 8000. So that's it. That's how we run these locally and verify that everything's running accordingly. Now that we know the file layout of our project, and we have tried running this Flask app locally, what we want to do is to try to execute it with the container. So first, in my terminal over here, I'm going to list the files, and we know we have our Docker file over here. So I'm going to run Docker and build my container. So I'm going to say Docker build, and I'm going to tag it as Flask-app, and I'm going to say dot, meaning from the current directory. That will use the Docker file in the current directory. So it's going to run. In this case, it built pretty quickly because I've already pulled all of the dependencies that Docker needs. All of the layers have been pulled before. And so now I have this Flask app in Docker. So if I say Docker image ls, I can see that Flask app is right there. Nothing has changed, and it was created a while ago, even though I just executed because I didn't change anything. All right, perfect. So now the next thing is to make it run, and to make it run, I need to specify the port. Now you remember that the contents of our app.py, if we concatenate those, you will see that it's going to use port 8000. So I need to map port 8000. So I'm going to say docker run, and then I'm going to do -p to map the ports of 8000 on the container to 8000 locally, and I'm going to run the Flask app container. So I'm going to execute, I'm going to run that, and it's going to run in the forefront. And because I was saying, hey, you should bind to any interface, any IP, you can see that it is binding on a couple here, localhost 1, and the other one is this IP over here. And that's why you can see here running on all addresses. That is what 0.0.0.0 will do. So next we're going to check here our local host on port 8000. So I'm going to go to my browser, and I am going to go to localhost port 8000, and then just like before when I was running locally, I'll try again these both URLs, both routes. One is a slash and the other one is a slash error. Well, that's good. And now that let's check our terminal over here, and you can see that in fact that's executing with a container, so it's perfect. And why is this useful? Again, it's useful because we're verifying that the container has no problems, is running, and this will help us try to deploy these and avoid any surprises, any problems that might come ahead. So that's how you verify these running locally. So now that you have a web application that you're running locally, let's take a look at what we're going to do with Azure. So what we need to do is we need to call app services. You can do that over here at the top, and this is the portal, by the way. So you search for app services, and here the first one that comes is this one. This is the right one. If we scroll down, we can see that there's a create, build, deploy, and manage powerful web, mobile, and API apps. And you can actually use a container for these, which is what we're gonna be doing today. So we're going to create the app service and go through the different various steps that you need to in order to launch this application. So you'll be greeted by this form that you need to fill out. You need to select a subscription here. I have a subscription that is this one that I want to use, which is my demo. I want to create a new resource group. A resource group is something that groups together all of the resources that I'm going to be using. In this case, I'm going to say Flask. Let's call it Alfredo Flask app. And I'm going to say OK. Then the name of the web app has to be unique. Do you see this at the very bottom? It says azurewebsites.net. So that means that this is a domain. So if I say something like generic like demo, he'll probably complain. The app name demo is not available because someone else has already used that. So I'm going to use the same name as my resource group. So I'm going to say Alfredo Flask app. And lo and behold, there's no one that has selected this as their subdomain for the application. And here in the publish section, you can select 3 different types. You can select the code. So if I'm running just the code, I can certainly deploy the code only, a Docker container, or a static web application. Well, in this case, we have a Docker container, so I'm going to select Docker container. The runtime for the operating system is going to be Linux. That's fine. The region, Central US is okay for me. And then we're gonna look at the app service plan. So here with the service plan, you have different options. One thing that I recommend if you're trying out things is that you can change these for using the free. Like if you don't see these free SKU or in size, then you can definitely change that. So if I create new, you can definitely change that. But this is fine for me. I don't need anything else. This is perfect. It's a free service, and I'm gonna take advantage of that. Next, I'm gonna say review and create, and this is going to go and validate that everything's fine. And it seems like everything's pretty good there. I'm gonna say create. So there you go. It's going to submit the deployment. Deployment is in progress. It's going to go ahead and tell me that this is going to take a few seconds, I imagine, and then it's going to say that the deployment is complete. And once it's complete, it will allow me to go to the resource and take a look at some of its settings. I'm back in the GitHub repository, and I've pushed all of my changes onto this repository, including my web app that, as you remember, has the app.py, and it is still exposing port 80. Now, I've changed that before pushing so that it doesn't go back to port 8000 as I've done for the local environment, because Azure will need something different. Now, the way I set up GitHub Actions to work with these, you can feel a little bit overwhelmed by the amount of configuration you will need. However, the actions right here in this button over there, it will make it very easy. All you need to do is search over here, and you can say Azure Web App, and a few different templates will come out ready for you to use. So if I scroll here, you have a few different options. Now remember that Azure Web Apps allows you to push some code. In this case, we're not going to push the code. We're not going to run the code as it is. We are going to run a container app. So we're going to select this one, which is deploy a container to an Azure Web App. So I'm going to click configure. And these will have a couple of things here. I'm going to keep scrolling over here so you can see what's going on. I'm not going to touch any of these options. I'm just going to leave them as is. The only requirement here is that I need to create a couple of secrets, and the secrets are Azure Web App publish profile over here. So that's what this action needs. So I'm going to create that secret, and then the other secret that we need is to create or to set the name of our web app. So you can see here Azure Web App name. Well, this is not exactly a secret. I'll have to put it right there, but the one secret that we definitely need is Azure Web App publish profile. Why is it a secret? Because it's supposed to be a secret, because it's a token that authenticates and allows modification to this application. All right, so now that we know that we need to create this Azure Web App publish profile, where do we get it? Well, here in the instructions, everything is pretty well documented, and you can just click on that link and follow up. But I'm going to change tabs here and go to my Alfredo Flask app. Remember, in Azure, I created this application, this web app, Azure Web App instance, and we have this get publish profile. This happens to be in the dashboard whenever I open this Flask application web app, and the name that we will need for this GitHub action to work is Alfredo Flask app. So let me go ahead and make that update right away, and we'll see where is this Azure Web App name defined. So Azure Web App name is right here, and we know that is Alfredo Flask app. So I'm gonna start a commit, adding GitHub action, and then I'm going to commit that file, and that's going to be present there. If I need to refer to the instructions again, I can look at the file, and Azure Web App name will have Alfredo Flask app. Again, if I go here, I can verify these. All right, so next we need to get this get published profile. I've already pre-downloaded that. And in fact, if I click here, it will download again. So it's alfredo-flask-app.publish settings, and it has a secret code in there, a token. So what I'm going to do is I'm going to copy that to my clipboard, and then I'm going to go back here to my repository, and I'm going to go to settings. So I'm going to click on settings, and I'm going to add that secret. I'm going to scroll all the way here, find this security section and click on secrets, and then click on actions. There's different types of secrets for different types of destinations. We want these to be used for actions. I'm going to click on actions, and I don't have any secrets right now, right? So I'm going to create a new one. So new repository secret. Now it needs to have a name and then a value. Now the name, it happens that, well, I don't remember what the name is, so I'm going to open my Azure Flask Container App repository, switch tabs, go to my workflow, go to my YAML file, scroll down, and it says it wants Azure Web App publish profile. So let's go back to Action Secrets. So it says Azure _ Web App publish profile. Then I'm going to put the value here, and that's the value that I previously copied to my clipboard, and then that's it. The action is ready to go and ready to be used. So that is all we need to set this action, GitHub action, all of the things that this GitHub action needs in order to be successful. Next, we will take a look at what are all of these components and what exactly is going on in that YAML file to make this a successful automation environment. Okay, so let's go through what you need to know in order to do automated deployments. We have our action already set with everything that it needs, all of the secrets, all of the configuration. It has the name of the web app. In this case, it's Alfredo Flask app, and it has the publish profile secret. So I'm here back in the repository on GitHub, and I am going to, well, a couple of things. You'll notice that there's a big red X here. That is because when I created the action, when I committed that file, the action got triggered, but it failed. It failed because I didn't have the secret. So the secret came in later. So if I click here, you'll see that there's a build and deploy container failure, and then it's we have a green check, and that's because later it was successful because I added a secret. However, that tells just half of the story. Let's go and take a look at the GitHub workflow and go through the action itself. So I'm gonna scroll now inside here so I can explain exactly what's going on. So the name, build and deploy container to an Azure Web App, you can change that to anything you want. This is meaningful enough for me, so I'll leave it as is. Then we have this Azure Web App name environment. That's the name of my application. And this section right here is pretty important because it tells us that whenever there's a push to the main branch, then a push or a change to any file in the main branch, it will execute this action, it will deploy. So we have some automation going. If you have a pull request and you merge to the main branch, this will trigger. So that's great because you have now a way that you'll have automated deployments when there's a change to the main branch. But you also have this thing oddly named workflow dispatch. That means that you can manually trigger this action without the need to change files in the GitHub repository, which is pretty useful. Next, the things that happen here are basically builds a container. And then once this container is built, it gets pushed to the registry inside of GitHub, which is specified right here. It's on ghcr.io. Why does that? Well, it builds the container and puts it in this registry, because then Azure Web Apps will pull that image from this GitHub repository, and then that's how Azure Web Apps can actually tell where to get that image from. You can see here on deploy to Azure Web App on line 76 that's the image that gets listed here comes exactly from the GitHub repository, or the GitHub registry rather, that has that image that we built in the previous step. So first it builds a container, pushes that to the GitHub registry, and then it tells, hey Azure, by the way, you have an image here you need to pull. So that's how it works, and everything else, well, you don't need to worry about it, because everything it's there for you. You can certainly play around and modify a little bit, but everything's ready to go. All right, so how do we try these? Well, there's a couple of options. I'm going to scroll all the way very quickly to the top. There's a couple of options. I'm going to go to the Actions section over here. I'm going to click there, and I can select the workflow of building and deploying a container to an Azure Web App over here. And then you can see that there is this light blue or light bluish section that says this workflow has a workflow dispatch event trigger, which means I get this button over here that I can click and say I want to run this workflow. So that's one way, and different ways if I make changes to main. So if I click this, you will see that there's changes here, but how about we make some changes to these, and let's click here, Flask. I'm going to make the changes directly into main. You perhaps want to use some pull requests, but here I'm going to make changes directly into the web app. So I'm going to go to the app.py. I'm going to click this, edit this file, which will allow me to commit my changes directly here. So I can say 200, and I can perhaps put an H1 tag here, right from GitHub Actions. I'm going to close this H1 tag, and I'm going to commit this. I'm going to scroll the way down. I'm going to say update with H1 tag, and I am going to commit the changes. Now, as soon as I commit, if I go to Actions, you will see that my commit is there and it has been triggered. Now, the same thing would happen if I run the workflow manually, except it wouldn't have these changes. So as soon as I make the change, so now we have automation going. So if I click here, you will see that first what it's doing is building the container. As you remember, the first step is to build a container and push it to the GitHub registry. So once that builds, it will go and contact Azure and make the deployment. You can certainly click on these items here and you will see some progress. You'll see that there's building and pushing going on, and the logging will be pretty fast and highly verbose. So I'm going to skip that, and it seems that it completed the job. So I'm going to go and take a look at deploy. Now deploy will go and talk to Azure using the published profile and everything it needs to get that going. Once it completes, then well, it completed pretty fast. Once it completes, it will get published to the URL where we said our Flask application is going to live. So if I go here and complete job, you can see evaluate environment URL, Alfredo, Flask app, Azure websites.net. Now that we have automation going, it is entirely possible to get into trouble. So I have the repository here, and let's assume for a second that I'm gonna merge some changes I thought they were fine, and in fact they broke the container. Now breaking the container, what I mean by that is that the container is going to build. If I make a breaking change to the Docker file, that will be immediately caught by the GitHub action, and no deployment will happen. But if the Docker file, if the Docker container builds fine and gets pushed to the registry, it can still be broken because when we try to make it work, it might not run. And the way we're gonna force that, or kind of like set the stage for that failure, is we're gonna introduce a syntax error here that will make these implode. So I'm gonna edit this file and make this change so that it has a syntax error, or it raise syntax error. So I'm going to do these, and then I'm going to commit the changes and say make the application break. So I'm going to commit that, and that will trigger our actions, and it will deploy it to Azure Web App. Now these will allow me to build a container successfully, push it to the GitHub registry, and then it will tell Azure that it needs to pull from that. However, when Azure tries to run this container, you will see that there's a problem here. So let's go and see the Actions tab, and you can see that this is running. So let's just wait a second until that completes. So now we've dealt with a broken container. It doesn't start. But what happens if you have the incorrect port? Well, let's make that change again. We're going to clean this up, make that syntax error go away, and change the port to something else. So I'm going to remove this syntax error so it doesn't bother us anymore. And here I'm going to put, say, port 8000, and I'm going to commit those changes and say setting up port 8000, and then commit those changes. And what this is going to do is, as you know, we have automation now. It's going to build this container, push it to the GitHub container registry, and then it's going to tell Azure that it needs to pull this new container and try to run it up again. So let's click on this one. You will see that it's building the container. That's going to take a few seconds, hopefully not too long, and then it will go back and deploy. So let's just wait a minute until this setting up port 8000 commit gets built and deployed and pushed to Azure.